So, Flyod cycle finding algorithm. As the name suggests, it is used for finding cycles. It can also be used to eliminate a cycle in a linked list. So here's a simulation. You have two counters, a slow counter and a fast counter. The slow counter traverses one node at a time, whereas the fast counter traverses two nodes at a time. So let's start. You have the slow counter here and the fast counter here. Now during the first iteration, the slow counter moves from node 1 to node 2. And the fast counter moves from node 1 to node 3 since it traverses two nodes at a time. Then you have the slow counter moving from node 2 to node 3. And the fast counter moving from node 3 to node 5. You keep repeating this, so something that I forgot to mention is that during every iteration you have to check if the slow counter and the fast counter point at the same node. So far as you have seen, they haven't done that yet. So next up, you again move the slow counter one node forward from 3 to 4. And you move the fast counter two nodes from 5 to 7. You keep doing this until the fast counter and slow counter are equal. So we move the slow counter from 4 to 5, and now you're going to move the fast counter from 7 to 4. So that's two nodes. 1, 2. And then in the next iteration, you move the slow counter to 6. And then you move the fast counter two nodes forward from node 4 to 6. So as you can see, we have the slow counter equaling the fast counter. So at this point, you're going to take any of the nodes. So you can take either the slow counter or the fast counter and take it to the first node. So I'm going to take the slow counter here. And now while you do that, you're going to have to change the pace of the fast counter to just 1. From now on it's going to traverse just one node at a time instead of 2. So you do the whole thing again until S equals F basically. So let's do it again. You move the slow counter one step forward. And now, as I said, you can't move the fast counter two nodes at a time from now on. You have to move it one node forward. So it moves from 6 to 7. And then again you move the slow counter from 2 to 3. And now you move the fast counter from 7 to 3. Now as you can see, we again have S equals F. So what this denotes is that this is the starting point of the cycle in our linked list. So again, you're going to now choose any of the nodes that you want. So, and fix the position of that node. So let's let that be the slow counter. And then you're going to move the other counter until the other counter's next node is going to be the slow counter. Let's simulate it and it will make a whole lot more sense. So you move the fast counter from 3 to 4, and in the next iteration you move the fast counter from 4 to 5, all the while keeping the position of the slow counter fixed. Then you move it from 5 to 6, and then you move it from 6 to 7. Now at this point you can see that f dot next is going to equal s. You see, f dot next is going to equal s. So what this denotes is this is the ending point of the cycle. So what you're basically going to do is now s dot next equals null. So this is going to remove this link, and now you're no longer going to have a cycle in your linked list. So that was a quick simulation of how Float's cycle finding algorithm works.